How do PLC timers function in automation? Imagine a factory where machines need to start and stop at just the right moments. How do they keep everything running smoothly without someone pressing buttons all the time? That's where programmable logic controllers, or PLCs, come into play. They are the brains behind many automated systems. One key part of their control toolkit is timers. But how exactly do these timers work? Let's break it down. PLC timers are like digital stopwatches inside the controller. They are used to create specific delays in automation processes. When a process needs to wait before moving to the next step, timers make that happen automatically. They work by measuring how much time has passed since they started. The timer has two main parts: a preset value, which is the amount of time you want to wait, and an accumulated value, which counts up from 0 as time goes by. There are three main types of timers used in automation. The first is the on-delay timer, or TON. When the input to this timer turns on, it begins counting. Only after the preset time has passed does the timer turn on its output. This is useful when you want to delay starting a motor or conveyor, giving the system time to stabilize first. The second is the off-delay timer, or TOF. It works in reverse. When the input turns off, the timer starts counting, and the output stays on during this delay. Once the preset time is up, the output switches off. This helps keep equipment running a little longer after a stop command, avoiding sudden shutdowns. The third is the retentive on-delay timer, or RTO. This timer remembers how long it has been running across multiple cycles. It keeps its accumulated time even if the input temporarily turns off. This is perfect for tracking total runtime or delays that need to add up over time. In electrical terms, PLC timers replace older relay timers that used mechanical parts or electronic components. Now, they are software functions within the PLC's program. They operate during the PLC's scan cycle, which is how often the controller checks and updates its inputs and outputs. The timers increase their accumulated value based on the internal clock, making timing very precise. In real-world automation, timers are everywhere. They help sequence operations, like waiting a few seconds before starting a motor after a sensor detects something. They manage startup delays, schedule periodic tasks, and ensure safety by creating specific time intervals. For example, in a conveyor system, an on-delay timer might ensure the motor runs for a set time before activating the next part, preventing jams or mechanical stress. Timers also have status bits or flags. These bits tell the PLC if the timer is active, counting, or finished. The program uses these bits to decide what to do next. For example, if the timer is done, the system can move to the next step automatically. So, in simple terms, PLC timers are like digital clocks inside the controller. They count time to control when actions happen, making automation smoother, safer, and more precise. They are essential tools that help machines work together seamlessly without constant human input.